In section 7.3, we are going to look at solving systems of equations using algebra instead of using graphing. So you will not have to graph in this section. The method that we're going to focus on for today is a method called elimination. So when you eliminate something, you get rid of it. So for us to do that, we are going to do so by adding our two equations together. Now, in order for one of your variables to eliminate or cancel out, your variables have to have the same coefficient, but one of them positive and one of them negative. So if we look at this first example, we can see here that in this example, I am set up perfectly for elimination because with my y's, in the first equation, this is a positive 1y, and in the second equation, this is a negative 1y. So they both have a 1, but one is positive and one is negative. So when I add these two equations together, 5x plus 7x is going to give me 12x, but 1y plus negative 1y, 1 minus 1 is 0. So those y's then are gone. They have canceled each other out. So then this is equal to 4 plus 20 is 24. So by doing that, I have now created an equation that I can easily solve by dividing each side by 12. So when my 12s cancel out over here on the left-hand side, I find out that x is equal to 2. Now, if you recall from section 7.1, when we were solving systems by graphing, what we were finding was the place where the two lines intersected, which was the point of intersection. And we know that a point is always represented as an ordered pair, which is an x comma y. So right now, we only know the x part of our ordered pair. To find the y part, we're going to take this 2 and substitute it back into one of the two original equations in place of x. It doesn't matter which one you use. So if I choose the top equation, which was 5x plus y equals 4, I now know that x is 2. So this becomes 5 times 2 plus y equals 4. 5 times 2 is 10, so 10 plus y equals 4. Then to get y by itself, I would subtract 10 from both sides. So these cancel out, and I find out that y is equal to negative 6. So that means my answer to this system is the point of intersection, the ordered pair, the x comma y. So my answer is 2 comma negative 6. That is the process of elimination. So if we move over here to the second example, on this example, you might notice that both of your x's have 6's, but both of them are positive, and we want one to be positive and one to be negative. So what we can do here is, instead of adding, in this case, we can subtract. We just have to make sure that we subtract the whole entire bottom equation. So that subtraction sign has to get carried all the way through. So 6x minus 6x would give me 0, so those are gone. When I have negative 3 minus a negative 5, minus a negative is going to become plus. So I have 2y is equal to, and then I have 3 minus a negative 3. So again, minus a negative becomes plus. 3 plus 3 is 6. So we have this equation here that we can solve by dividing both sides by 2. And when we do that, we find out that y is equal to 3. So just like we did on the last example, we are going to now take that value, this time substituting in for y, and put it back into one of the two original equations. Doesn't matter which one you use. I'm just going to use the top one, which was 6x minus 3y equals 3. I now know that y is equal to 3. So 6x minus 3 times 3 equals 3. 3 times 3 is 9. So this becomes 6x minus 9 equals 3. And now I need to solve this for x. So I'm going to add 9 to both sides. So these will cancel out, telling me that 6x is equal to 12. And then if I divide both sides by 6, I find out that x is equal to 2. So that means my solution, my point of intersection, x comma y, make sure you keep them in that order, is 2 comma 3. So if we look at this example here, question number 3, we can see that we don't quite have this example set up the way that we need it. I don't have the same coefficient or the same number on my x's or on my y's. So you can make the decision if you want to eliminate your x's or eliminate your y's. I'm going to choose the y's here because one already is positive and one is negative. But the top one has a 1 and the bottom one has a 2. If I wanted the top equation to become positive 2y, I could make that happen by multiplying by 2. The only thing I have to make sure of is that I multiply all the way through the entire equation by 2. So I'm going to multiply this entire equation, distributing to here, here, and here, all by 2. So I'm going to rewrite that then, and that's going to become 4x plus 2y equals 4. Now the bottom equation I'm leaving alone. I'm not changing that one. So that one's going to stay 3x minus 2y equals 17. So now if I add these two equations together, 3x plus 4x is 7x. Positive 2 minus 2, so 2y plus negative 2y, those are going to cancel each other out, so my y's have been eliminated. So then this is equal to 4 plus 17, which is 21. So now I have an equation here that I'm able to solve by dividing both sides by 7. These cancel each other out, and I can say that x is equal to 3. So to figure out what y is, I'm going to go back to the very beginning and use one of the two original equations. So if I choose the first one, the first equation was 2x plus y equals 2. And I now know that x is equal to 3. So this becomes 2 times 3 plus y equals 2. 2 times 3 is 6, so 6 plus y equals 2. And then we will subtract 6 from both sides. So these will cancel out. And I can say that y is equal to negative 4. So then my point of intersection, my ordered pair, would be 3, negative 4. So this is the solution to the system. As we move over to example 4 here, we can see that on example 4, none of these variables are going to eliminate if I just add the two equations together the way they are right now. So we're just going to have to make a decision to either eliminate x or eliminate y. So let's say that we decide to go with the x's here. So right now, for my x's, I have a 3 and a 5. So what's a number that 3 and 5 both divide into? 15. So if I want to make one of them become a positive 15, so let's say that I want this top equation to become a positive 15x. So that means I'm going to need to multiply across the top by 5 to each of these. So then on the bottom, if I want that x to become a negative 15x, I'm going to need to multiply by negative 3 there and distribute that all the way through. So when I do that, my first equation is going to become 15x plus 25y equals 50. And my second equation will become negative 15x minus 21y equals negative 30. The important thing to notice here is that when I add these together now in their new form, 15x plus negative 15x is going to cancel out. So I will have successfully eliminated the x's. 25y plus negative 21y would become positive 4y. And 50 plus negative 30 becomes 20. So now I can divide this by 4 on both sides and find out that y is equal to 5. So now to go back through and figure out what x is then, I'm going to substitute this back into one of the two original equations. So if I go with the top equation, which was 3x plus 5y equals 10, I now know that y is 5. So 3x plus 5 times 5 equals 10. So that becomes 3x plus 25 equals 10. So to solve for x, I'm going to subtract 25 from both sides. So those are gone, meaning that 3x is equal to negative 15. And then divide by 3 on both sides. So these 3's cancel. And I can say that x is equal to negative 5, which means that my ordered pair here would be, make sure you keep them in order, negative 5, 5. So we have two more examples to look at here.